Hey there! Welcome to today's Explainer, where we're going to transform a pretty complex scientific mystery into a magical story about the night sky. Whether you're a curious kid or, just a kid at heart, get ready to become a cosmic detective with us. We're going to look up, way past the clouds, and uncover some absolutely incredible secrets of the universe.
Okay, let's dive right into this magical question that pretty much every single kid asks the very first time they look up at the dark sky. Why do those tiny little lights seem to dance and flicker up there? I mean, it literally looks like someone is way up there flipping a light switch on and off, or kind of like the sky is just full of flashing fireflies.
We all know the classic nursery rhyme, right? It's usually one of the very first songs we ever learn. But the scientific reality behind what those stars actually are and why they look the way they do, well, it's honestly even more fascinating than the song itself.
Section 1. What are stars really? Let's transition from the song to the science.
First things first, we've got to bust a really big myth about what is actually floating up there. Despite how we've all drawn them with our crayons, stars are not pointy shapes at all. Even though we all call that familiar five-pointed shape a star, nothing in outer space actually looks like that.
Instead, a star is actually a massive, round ball of glowing, super hot gas and plasma. They're mostly made up of hydrogen and helium, and they're powered by this giant thermonuclear reaction happening right at their core. This unbelievable process is called nuclear fusion, and it radiates intense heat and bright light all the way across the vastness of the universe.
And there are an incredible number of these massive glowing stars out there in the cosmic ocean. Scientists estimate there are about a septillion stars in the universe. That is a 1 followed by 24 zeros. To put that gigantic number into perspective, there are more stars in the universe than there are grains of sand on every single beach on Earth combined. It's mind-blowing.
Section 2. Magic dust and star nurseries.
So the really crucial question is figuring out where these billions and septillions of giant glowing balls actually come from in the first place. They don't just pop into existence out of nowhere. Stars are actually born in these beautiful, giant, floating cosmic nurseries called nebulae. Just imagine an enormous, quiet cloud of cold, magic dust and gas floating peacefully in the galaxy. That is exactly where our story starts.
Let's watch how this actually builds into a brand new baby star. Step 1. Cold gas and dust float quietly. Step 2. Inside that cold cloud, gravity acts like a giant invisible hand, pulling all that space dust and gas closer and closer together. And step 3. As it gets squeezed, it starts to warm up, until eventually it gets so incredibly hot that it ignites and starts to shine its very own light. A new star is born.
Once they're born, these stars burn for millions or even billions of years. And just like the flame on your kitchen stove, they actually come in different colors depending on their temperature. Blue stars are the absolute hottest, burning at tens of thousands of degrees. Red stars are cooler. And yellow stars sit right there in the middle, warm and steady, just exactly like our very own sun.
Section 3. The Great Atmospheric Dance.
Now that our giant ball of hot gas is shining brightly in space, we need to trace how its light travels all the way down to our human eyes on Earth. This is the real secret to solving our twinkling mystery. Picture this. 1,000 years ago, starlight leaves its star and travels in a perfectly straight line through the quiet emptiness of space. But just 1 second ago, before it reaches your eye, it hits Earth's atmosphere. Think of the atmosphere as a thick, swirling jacket of air that surrounds our whole planet. It's got different layers, and it is constantly moving.
This atmospheric jacket of ours is full of hot air and cold air that's always shifting around. When light passes from space into this air, it bends. This bending is called refraction. Because the pockets of hot and cold air are always moving, the atmosphere basically acts like a wobbly, shifting dance floor that bumps the starlight back and forth as it tries to squeeze its way through. Because the light has to rapidly zigzag its way through this turbulent, wobbly air, it creates an amazing optical illusion for us right now. By the time that tiny pinpoint of light reaches our eyes, it looks like it's shifting its position and changing its brightness. It literally looks to us like it's dancing.
The fancy scientific word for this twinkling phenomenon is scintillation, but is entirely an illusion created by Earth's air. In fact, if you are an astronaut floating in a spaceship high above the Earth with no thick, wobbly atmosphere getting in your way, You would see the stars shining perfectly steady, no twinkling at all.
Section 4. Steady planets and dancing stars.
This actually brings up a really fun trick you can test out yourself the next time you go out into the backyard for some stargazing. Have you ever noticed that some lights in the night sky twinkle wildly, while others just glow steadily? Well, stars twinkle, but planets usually don't. Because stars are so impossibly far away, their light reaches us as a single tiny pinpoint that gets easily bumped and bent by the moving air, making them dance. Planets, on the other hand, are much, much closer. They appear as wider disks of light. This larger beam of light is strong enough to power straight through the atmospheric wiggles without getting distorted, so planets look perfectly steady.
Now you might be wondering, but wait a second, if our sun is a star, why doesn't the sun twinkle during the day? It's a fantastic question, and the answer is that the sun is simply so incredibly close to Earth compared to all the other stars. Its beam of light is so wide and bright that those tiny zigzags caused by the atmosphere are completely unnoticeable to our human eyes.
Section 5. We are made of stardust.
As we wrap up this explainer, let's look at one final truly beautiful connection between you and this massive cosmic story. You see, when massive stars finally run out of fuel after millions of years, they don't just quietly disappear. They can explode in a spectacular event called a supernova. When they do, they scatter all the wonderful elements they created inside their hot cores, like the oxygen we breathe, the carbon in our skin, and the iron in our blood, all the way across the galaxy. Over time, those very elements gather together to build new planets, and eventually, us.
The wonderful children's musician Alina Celeste actually wrote an astronomically correct version of the famous lullaby we talked about earlier. She sings, "Now I know just what you are, and I know I'm made of stars." And it is scientifically true. You, me, and everyone you know are quite literally made of ancient stardust.
So, what magical secrets will you look for the next time you gaze up at the night sky? The universe isn't just something far away. It's right here, inside you. I hope this explainer leaves you feeling deeply connected to the cosmos. The next time you step outside on a clear night, look for a steady planet, find a dancing star, and remember exactly where you came from. Keep exploring and keep looking up.